Good morning, Safe Spring Saturday Seminar Series viewers. Thank you for kicking off your Memorial Day weekend with us. Today's guests, Team 10497 SwampBots, are not only the Design Award finalists at the Florida State Championship, but also have been an inspiration to our team.
The SwampBots have designed an awesome modular chassis design, and they're going to share that with us today. So we welcome the Northeast Florida Inspire Award winners, SwampBots, as they share with you SlickBot, custom, adaptable, competitive. Hello, SwampBots.
Hi, I'm Nick Sanders, and like I was introduced, I'll be talking today about our SlickBot and some of the design processes that went through last season and this season to adapt and learn from it. So the purpose of the SlickBot really boiled down is to bring a custom and highly competitive drivetrain design within reach of every single team in our league. In doing so, we are trying to incite growth and learning and education through robotics by giving them hands-on development skills in CAD process and fabrication process. So it all started in our off season of last year. One of our goals was to create a custom aluminum machine side panel drivetrain. So we spent around 30 to 40 hours messing around with different parts, and we finally ended up deciding on using Rev as a build system. So this is our finished product, as you can see right here. We decided on a 6-wheel drive, 20 to 1, two 20 to 1 motors powered on a 1-to-1 gear ratio for each drivetrain. And as you can see here, we're using a stealth wheel and 2 omnis on the corners because this gave us a lot of maneuverability while maintaining high speeds. So as for connecting, we decided to use rev rails on each side panel and then connecting together in the middle. So these rev rails are directly connected to the side panel. From there, we use aluminum H brackets that are machined also from stock aluminum for the drive panels, and connecting those 2 drive panels together, we're using aluminum L brackets that came from the rev kit of parts. So some really good features about this design was that it's very modular. All of your structure can also be used as attachment. It's not just empty space. So anywhere there's a rev rail, you can build attachments off of, and it was very good in that sense. It was a very fast drivetrain. It was very maneuverable, and allowed you to perform any task you really needed to get done. Another thing is our chain run was very successful in how we did it. So we did it in one continuous run by using a method called idler sprockets, which raised your chain above your other motors, so you could have a very long chain run. Some of the, I would say, downsides of this design, however, was that when you wanted to make new attachments and you wanted to put them in these rev rails spanning this length right here, you had to actually remove the H brackets and L brackets to put bolts in. And this really slowed down like the brainstorming and fast iterative design process. Another thing was these L brackets were not very strong connections. So when you pick the robot up, you could shift it side to side almost, and would bend a little bit inwards. It still didn't fall apart, thankfully, but it was not as strong as we would have liked it. We also were not very efficient with the space in our wheel channels, as you can see in the bottom right. Because it was our first time doing it. We didn't really know how many spaces you need, how many axle collars, where they went. So that's something we've definitely learned from. Another thing is having these rev rails on the outside instead of the inside of the side panel actually increased our total width by 30 millimeters, the width of 2 rev rails, which really made you shorten up the inside of your drivetrain, which became a problem later in the season with the 4-inch stone trying to come through. So we actually did compete the first half of our season with this drivetrain. We put a 1-stage slide system on it, and having this robot done at kickoff before the season even started was very instrumental in letting us prototype and find designs that we thought would work for the season or would help us out later. So it really goes to show that getting your drivetrain done can do a lot of help for your team's design process. So we ended up not actually, so this is the robot we ended up using, high quality picture for sure. So we were able to achieve a 4-stack with this, which was a pretty good for our first 2 meets. but we knew that we wanted something better. So we did a mid-season redesign. We spent 30 hours in CAD over only 1.5 weeks just on the new drivetrain. So we came up with doing that was to use Go Build and Mechanic wheels with Andy Mark motors and sprockets. And we wanted to make sure that we use the knowledge that we learned from the other drivetrain, such as we weren't really happy with the connections, and we wanted to be a little more conscientious, not very good speaking.
I'm sorry, Nick, we just lost your audio for some reason. Can you? That. Please continue, Nick.
All right, so we decided to do a mid-season redesign because we wanted to have a little more a little more maneuverability, accomplish a higher stack than we were already getting. So we spent around 30 to 40 hours in CAD, tossed around different ideas, and what we eventually ended up with is this Mecanum chassis using GoBuilda Mecanum wheels and Andy Mark motors and chain. And we wanted to make sure that we, took the knowledge that we had learned from our tank. The main factor being that we weren't really happy with our connections. So we did is we switched to peanut bars and churro bars, as these are the churros and these are the peanut bars. The reason being that these were very strong and they're also cost effective because we repurposed them from previous game elements, such as the rescue, the mountain and rescue. So we kept our 20-to-1 gear ratio because that was a very good amount of speed and also being able to control it well. We also want to keep our modularity. So the way we did that, instead of having rev rail span across the length of our drivetrain, we made a 16 millimeter isometric grid hole pattern. Now what this means is that these holes right here are 60 millimeters down and 60 millimeters to the side from each other. The significance of 16 millimeters is that it not only fits Rev, but also fits Tetrix products. So we wouldn't be constrained to only one build system for attaching to our side panels. So some of the drawbacks of giving ourselves such a tight build period in the middle of our season because we redesigned, we did not get to calculate our chain tension. So it left us with a really sloppy chain tension, as you can see here, and this caused problems such as it would sometimes skip teeth or even completely fall off the sprockets in some case. However, we did have the foresight to create chain tensioning slots, which you can see right here, even though we didn't know what we would use them for. So later on in the season, we used blocks or Delrin circles that we cut to length. And Delrin is a very tough plastic that's also smooth enough for chain to slide over it. So what we did is we drilled holes into our chain tensioner or into our Delrin and put that into our chain tensioning slots and then pushed down on the chain enough that it would get rid of all the slack. And we were able to drive properly again. So calculate your chain, it's worthwhile. Later on in the season for our attachments, even though we hadn't built the attachments prior to the side panel, because of our hole pattern, we were able to 3D print an intake around this very effectively. And even though we had like a really short amount of space in our wheel channels, we were able to utilize CAD again. I believe we spent around 16 hours on this individual intake, and there were a couple more iterations. So as you can see, it is powered by Rev servos instead of motors, and they're on a 2-to-1 gear ratio to try and spin these 2 millimeter stealth wheels fast enough to bring the block in. And it did work pretty well for us. Although looking back, we should probably have tried and utilize motors instead. So once we had intake in the block, we need to obviously bring it over our robot and stack it. So we decided that we wanted to stack around 8 stones, at least for our first iteration. But we wanted to make very precise build decisions to shorten our build period. So one of the things we did was we only used one stage of slides, as you can see right here. These are Mizumi SAR 330s. And this allowed us, using this very long arm on a rotation, to stack 8, I believe it was 8 stones high. So we got, for a shorter build period, we still got the kind of score we wanted. And as for our gripper, we went through a lot of iterations of this. So as you can see, it was a lot more, before we found the optimal one, which was this right here, using Rev products. So the idea is it would rotate on a servo. As you can see, it's being held right here by a servo. And this would allow us to move to a grabbing position and a stacking position. It would then use another Rev servo on another arm, pushing a rotation point, being this structure right here with these wheels. And that would clamp the back of the stone and the peg together, as you can see right here. This worked pretty for us, so we decided to 3D print to consolidate can't hear them if they're talking.
Can you hear me?
1 second. All right. I think my audio is back now.
Can you hear me?
Yes, I can.
Okay. Feel free to take it away.
All right, this is going great. So do we know where we left off?
Yeah, you were talking about 3D printing to consolidate your design.
Okay. Yep. So we 3D printed to consolidate the design. So this was our design condensed as much as I could get it over the year. We learned a lot from creating these drivetrains and testing them during the season. And we knew that we wanted to pursue the SlickBot and make it something that was, the best of our engineering capabilities for the rest of our league. So we began working on SlickBot version 2, keeping in mind all of the things we had learned, specifically that peanut and churros worked very well for us as connection. And that we liked the 20-to-1 ratio, but we still wanted, to have a little bit of wiggle room in our design for that. So here is the unofficial release of the SlickBot. This is a render done in Fusion. This was created in Onshape actually. And so this is just, the main body. I'll switch now to a side view. So as you can see here, we are using 3D printed pulleys and to another 3D printed pulley. And the idea behind this is that using 3D printed pulleys, that you can change your gear ratio to whatever you want, and it can also fit any build system. Regardless of its Tetrix, Go Builder, or Rev. All it requires is a locking motion hub, as you can see here, of some sort from whichever build system it is. And then this is another great feature of using belts and pulleys instead of chain, is that you can very accurately calculate your center to center distance needed to get a perfect tension on your belt. This means that you technically do not need a belt tensioner, and it should be fine for the entirety of the season. However, we still created the capability to tension the belt if there were some manufacturing failures or whatever along the way. So what this is right here that you're looking at, this center piece is a Go Build a standoff with, they have like a acetal or a Delrin like tensioner, which is what this piece is right here, that rotates on the standoff. And the entire point is to tension belt. So this is in a slot the same way as our other ones were. So you can raise it up and down and adjust the tension for whatever you need. This is also showing that there's another 3D printed pulley on the wheel. And these are Go Build a Mechanim wheels, but the whole design can be adjusted to whatever build system you need. That is just something we need to coordinate beforehand. So I'll bring it back a little bit. So as you can see, again, we're using the peanut bars and churros to great effect. We're actually using 3 peanut bars this time, and we're leaving the front open, because as we saw this year, it was very necessary to have that if you were doing a pass-through of some sort. There'll still be capabilities to mount peanuts there if necessary, but that all depends on the game and what kind of requirements you'll need for that. So the main factor of this is it's all able to change, it's all modular, and it's all very easily changeable. So this isn't like just a package, here you go, make it. We can fit any design and any build system in here because of the design choices, such as using 3D printed pulleys or using churros, or having the grid pattern. It all depends on what your team is willing to work on. So that's what I have for Mechanim, and I think we'll switch over to Tank now. So it's pretty much the same concept. It has the same placement of peanut bars in the back, in the middle. However, it's using the 6-wheel drive as we featured before. This one is pretty similar to what we had before. Some of the key differences is that we decreased the inside width of the wheel channels, and this lets you have more space in between your inside panels on the inside of your robot, which again is very useful for this year. The way we did this is by using only one axle collar, as you can kind of see right here on the wheels, because everything is pressed to fit, so that you only do need one axle collar and there's no wiggle room in the wheel channel. And then we just, again, using the churros that you can cut to specific lengths. So right here, we are again featuring the direct, like one loop of chain. So this is a drive sprocket right here. This is another drive sprocket. They actually, you can't see it, but it loops under this wheel, over this drive sprocket, under this wheel, and then over, these are idler sprockets, over these idler sprockets, so it does not fall back onto the previous chain run, and over this drive sprocket, under this wheel, and connects back. One major feature that we did change is that we actually do now have chain tensioning available. So this is a little different than the belt. It is another go build a standoff. Whoever is using a ball bearing bushing, the purpose of which is that you push it up into the chain and create tension there, and then the ball bearing would spin, so there wouldn't be any additional friction to the chain, and you wouldn't lose any speed because of that. So that is what I have for the design. And I'd like to take some specific questions if anyone has them. Before I go there, actually, one more thing is, now that I'm done, now that you've seen the design, how do you actually get this? How does your team, who doesn't know anything about CNCing or CAD or whatever, actually use this and be able to utilize it? So some of just the base requirements is that this will cost around at least $120 for the aluminum churros, peanut bars, nuts, and bolts, and that is assuming you have every other component, such as the wheels, the sprockets, the chain, etc. So something you should consider is, do you have a starter kit, and do you, from some major supplier like Rev, AndyMark, or not AndyMark, Rev, Tetrix, or GoBuilda, and that can offset the price quite a bit and be very helpful. And then another thing is these are panels, they're aluminum panels you have to custom machine using a CNC or a milling machine. Or you can use a water jet or plasma cutter if you happen to have one of those. So, that might, seem kind of like something unattainable, but there's a lot of people around you, wherever you are, that use them, and there's help out there. And if you don't know where to go, please contact us, and we will work with you on finding the help necessary for that. And I will have contact links up after this. And then finally, as far as contacting us, please join the Slick Discord. I'll post a link in the chat, and you can also email swampbots@ftc@gmail.com for a direct invite link to the server. So that is all I have for my presentation today.
Okay, I have a question. How does this differ from other available options, such as the AndyMark Tile Runner series?
Yeah, so I think the AndyMark Tile Runner, we actually had one. We bought one, I believe, 3 years ago. And it's been very helpful in designing this robot and helping our team progress. But some problems with the Tile Runner is that it is just a kit. You have to buy all their products. You have to conform to what they expect it to be. We also feel like there's less connections on that, like modularity, what you can build on, than there is with this. So the idea of this one is it is more modular. It can conform to what you need. It is a lot cheaper as well. It's a lot cheaper. And it's, it's more relevant from a team's perspective. Like us who have tried to build competitive robots are going to keep building them, and it's more relevant to what our league needs right now, what we feel like developing teams need. That the fact that you're going to learn a lot from it, because this is just the basics of FTC, of really CADing and learning how to properly design machines like this.
I have a question. Your CAD models, they look amazing. I was wondering, what CAD programs did you work with to complete this, and would you suggest that program for other teams?
Yeah, so we started last year in Creo, and then we actually switched to SolidWorks, and then in Fusion, and then Onshape. So we've pretty much used every single CAD software there is available to use. And I think they all have specific things they're good at. But if you are a rookie team and you're looking just for the best overall experience, I would probably suggest Onshape. They have also a lot of support in the FTC Discord. Um, you should also join that if you're looking for some help. But I feel like they do have the most like well done package for simplicity and making your designs. I will say that these renders are actually in Fusion 360, so it is worth getting a Fusion 360 account just for the renders, so you can take shots like this.
I have another question. Your design looks really cool. What testing have you done to prove the effectiveness of these designs?
Yeah, so like we said, we use these designs, in competition. We've definitely battle tested them by trying to, ram other robots at state, get some action in, and we've come off like almost completely unscathed. So they're really robust designs. The churros work to great effect of holding it all together. It's been the iterative process of actually using the designs, learning all the failures. That's why we didn't release it last year, because there's so much wrong with, and so much you can improve on. So it's really been tested out, and we'll continue to test them, like these new designs in the off season.
What can teams do if they have other build systems or other special requirements in regards to the chassis?
Yeah, so I think that it comes back to my point, that we try to make these as adaptable as possible, and that like I was saying, the whole patterns, they don't just fit Rev, they also fit Tetrix, and we are also working on getting GoBuilder patterns, for example, and maybe using some more GoBuilder products. So our team is working on putting out more than just these are like primarily Rev. We're also trying to put out Tetrix and GoBuilder side panels and different hole patterns. But the main thing is, don't, like, if you have a hybrid, even of you have all the different build systems, whatever works, and contact us, and we can help you get through that and design around it.
So I believe your team started as an FLL team. What advice do you have for FLL teams transitioning to FTC?
Oh boy, that's a tough question. So the skills you learned in FLL, as far as structure, and building your assemblies around like Legos, it does hold true for the most part, just like where you put your supports and all that. But it is still a completely different game, that everything's larger, there's less little pieces you can put together. So I would say really experiment with building a drivetrain. If you want to build it out of parts, learning how like the forces actually affect your robot, what kind of strengths you need. Get a slick bot, you can learn a lot by doing that. And then you keep the judging, like a lot of FOL is judging. So really try and enjoy your judging process in FTC2. Do more community outreach, which some teams did do that in FLL, but keep doing that, and work at your own pace. Don't jump into it too hard and try and go win worlds in your first year. Work at your own pace, and keep enjoying the judging process, and build motion components so you can learn about the forces that act upon them.
Little fun question. Do you have any guesses on what the game's going to be next season?
I hope it's a ball shooter, because it's been a while since we've interacted with them. So yeah, I definitely hope a ball shooter. Also because I'm working on a turret, so that would help me if I got a jump start in the season for once.
That's what I'm hoping for as well, because we haven't had any experience with ball shooting.
Mm-hmm.
But back to a technical question from the YouTube chat. Do you find Mecanum wheels to be more reliable than other wheel options?
So Mecanum wheels, I would actually say, I mean, they're pretty much less reliable because of how they're made when strafing, and at least in autonomous, I would say. So the reason behind that is you have to be running at a very slow speed to be able to go in a straight line effectively, if you don't want to do a bunch of coding to get around that. However, in driver control, they're unparalleled to anything else you will find. Even just a swerve drive, if you've heard of that, it cannot touch the speed and the reaction time of the cannon wheels when strafing to driving straight. So like a tank, it's easier to control. It's easier to run autonomous, but cannon wheels are a massive difference in driver control and the ability of, kind of unleashing your drivers to do what they, the best of their abilities they can.
Here's another question from the chat. How did your team come up with their name?
Well, I think we heard from someone that like when you get to state, everyone's got an identity. Everyone's there are some like Titan teams out there that everyone knows. So we're like we're the only team in like a 45-minute radius, probably more than that back then. So what do we have local to us? So we happen to be in the University of Florida's college town, which they their whole theme's gators and the swamp. So we decided we'd stick with that, which is we had an FLL, and we'd make that our theme and try and stand out in that sense.
Okay, that's very cool. Last question from the chat. How would you compare your previous chassis to the SlickBot chassis in terms of effectiveness, ease of build, etc.?
So we haven't actually built it yet, and that is something we're going to work on. However, from a conceptual standpoint and what we've learned, I can say that this is head and shoulders above it. There's, like I said, a lot of problems to the last one. Main thing, the chain tensioning, and not having a lot of width in the wheel channels. So I'd have to build it before I say it, but I would say that both of these designs are going to be much better and more effective, stronger, all of that than our other designs.
All right, that's all the time we have for today. Thank you so much, Nick, for showing us about your SlickBot.
Yeah, thank you very much for having me.
Thank you, SwampBots, and thank you, Nick, for being such a pro through the technical difficulties. Next Saturday, May 30th at noon, SSS